So, the Environmental Protection Agency has been studying Miller Creek regarding ammonia nitrogen concentration. For many years, the concentration level has been 2.3 milligrams per liter. We probably know what that is, but maybe not 100% yet. However, new golf course and new housing developments are raising concerns that the concentration may have changed. What's important there? What is that not telling us? A direction. Not telling us which way it's changing. So any change, either increase or decrease in the ammonia nitrogen concentration can affect plant and animal life in and around the creek. Based on recent studies of Miller Creek, we may assume that the ammonia nitrogen concentration has a normal distribution. That's really helpful for us because now I don't have to make a graph of like 8 different dots. Here's our sigma. Recently, a random sample, there's random, 1 is 8. Water test from the creek gave the following X values. So those are just the amounts of, and I think I changed this, those are the amounts of concentration of ammonia and nitrogen in the water. Construct a statistical test to examine the claim that the concentration of ammonia nitrogen has changed from 2.3 milligrams per liter. Use the significance level alpha equals 0.01. So just like before, we're used to going through these and kind of figuring out what we need and what we don't need. So state. What is the first part of state?
Are we doing our overall population or our sample population?
It's the one that you wouldn't say sample population because don't say it sample population because it contradicts itself. But it's the one that it expands to. So that one I might want to come back to. Let's do this first. So what parameter am I defining? What's the first word? So it's going to be the mean what? Mean concentration of ammonia and sometimes I go really detailed and write population there, but I'm not going to be super detailed. So it's the mean concentration of ammonia and nitrogen. What? And so I could say in the creek or in the water, and that might help me. So one thing I do want to write there is, I'm going to probably go ahead and do my units, which I could do later. But so now that I know this part, it's these for what? So I like to rewrite this one a little bit as each of your ends, 2.1 is a what?
Water.
So this is all of the what?
Water.
So all possible water values, all water in. Somehow you're talking about the entire Miller Creek. Whether you want to do all possible samples that could be taken from, all water in, all water that could be tested. So that one kind of got a little bit easier to start with mu to kind of go backwards. Especially because population is the one thing that gets a little tricky. And in that one, it shouldn't be hard. It shouldn't be like there are 2 options for this one of what it could be. Like that one that I talked about was. What's next? So what's my null hypothesis going to be? So because I write it here, it's not going to be, I wouldn't count off if you didn't write it with defining it. And then, what's my alternative going to be?
That it does not equal something more than
We don't know enough yet to be able to answer this question, but I would imagine that some people say, well, why don't I always do not equal to, so that I don't have to think about it? You are less likely to overturn it if you do not equal to than you are with a one-tailed, because if you have an idea of the direction, you have more power. But we're just not there yet to have that conversation. And then what else? And did it give us alpha in this problem? And what's the first part of plan? What's the first part of plan? What is my method? So I have to kind of make a decision here. It's a one sample what? Why is it Z?
since sigma is this.
So it is a one sample Z what?
Test.
So what do I put here? So I actually write what? And then so I need to write with that. Oh, we also got an email that they're going to do AP review day as a district again. They did like 2 years ago. I might have to.
Just for history though.
I have mixed opinions.
Because we went to Greenville.
Right.
And they were just like, see these stations, and the game was like,
Well, I am so picky specific that I would not be helpful to another class because I'm so critical. But for you guys hearing someone else talk about it, it could help or it could confuse you. So like it depends on which. Sullivan did it 1 year and she actually really liked it to an extent. Like there are parts that she liked, parts she didn't. All right. What's my next condition? And it was stated that what?
there's no other
So what do I need to write?
there's no other community.
More specific.
Population.
And it did say approximately, right? Oh, it said normal. And then so
We can.
what's my next condition?
Independent.
What do I write with independent?
10% condition.
Which is
10's already guessing this last thing we put it in.
what was our n for this problem? So this one I have to think about. This is why sometimes I write this a little bit different. There's at least 80 all water in Miller Creek. Sounds kind of funny.
At least 80 water.
And so that's why sometimes I come back here and choose to go something like that, just so that it makes more sense and I'm not like changing anything. So I'm basically looking at it as a bunch of individual things that can be collected. That doesn't really matter, but it would be really weird to write this about that. So there at least, whether I wrote that or not, what is it? There are at least
80 water tests.
80 possible samples I could have taken of the water, tests that could have been conducted on the water, something like that. It worded it as water tests. So I'm going to say 80 possible water tests. How do I need to finish that?
Using water from Miller Creek.
So make sure you specify Miller Creek. Alright, so what's my first thing that I need? What do I need to do right now? Find your numbers. So the only thing I'm actually going to need from this one is X bar, but usually I need X bar and S. So usually I would always type it in a list. For the sake of it right now, if that's all we're finding, I think somebody can do it once and tell us what they get. Somebody who's got it. So somebody who's typed it in, what do we get as our X bar? 2.5825 of 125. And again, it would probably be better to write milligrams per liter here, but this is where then it gets really messy up there, so I choose not to write my units. Then what's next? Or what else do I have? And it gave me sigma, which was what else? What else? From the claim was, and the part that we haven't talked about why we need yet, this is a two-tail, and alpha equals what? 0.01. So which equation are we going to use? Give me the symbols.
X bar minus U over sigma.
And out of habit, I just write this because this is what I'm going to plug in. Like up there, I write X, but it really is probably more correct to write mu naught, which is what the number that goes there. So what is my X bar? 2.5125 minus divided by what's sigma over square root of And so we're dealing with a z, and how many do we usually round z to? 2. So I'm really big about this chapter about I always, if I'm dealing with z, I round it to 2 decimals. If I am dealing with t, I round it to 3 so that I'm using the right one, and I understand that I'm using the right one. The fact that you rounded 2 or 3 decimals I'm not going to grade it differently, but it helps you remember to use the right stuff after this. So what do we end up getting rounded to 2 decimals? All right, so without thinking, where do I draw a line? What kind of number is that? But the next question I ask myself after I draw a line is what? How many, where do I shade? So, where do I shade if it's two-tailed? So, you're actually going to do this and this. So, this is like 2 and this is like -2. Even though that's the only value that we got. So, right now, let's just talk about it as that right side, which is the one that makes sense. So, find the area of that shaded right tail, whether you use the yellow sheet or your calculator. Yeah, I want to go over that with the calculator again. What button do I push in my calculator? And I go to... So what's my first option? First input? What do I want my lower to be? What do I want my upper to be? I leave my view at 0, my sigma at 1 because I'm dealing with z. And when I hit enter, it's going to give me the area of this tail, which is what? Is everybody good with getting that? But p-value is the total shaded area. This is a symmetrical graph. So if this is 0.0228, what is this? So this two-tailed thing here is a reminder that that's not my answer. My answer is actually 2 times what I get when I do that.
It's always probability of just what you get times the number of tails.
Yes. And so that gives me what?
0, 4, 5, 6.
And usually I'm not going to write it there and write it here, but for the sake of me talking about that. So our p-value is 0.0456. Our alpha is what? And so I have to make a decision here. I want to know if it is or is not what? So is it less than? Again, is it wrong to say that it's greater than? No, but it's just the way that I write my sentence so that it's all positive connotation or all negative connotation. So this should give you a little insight here where if I knew that it was going to be greater than, I would be twice as likely to overturn it as I would if I didn't know which one it was, because now I have to multiply my p-value by 2.
You say that again?
Like choosing a direction if you can, because I had to multiply this by 2. So here, if I knew that it were above, your alpha would just have to be lower than that. But now because I didn't know, my alpha has to be lower than that. It's less likely.
Above what?
If I knew that I was testing just that way, as opposed to testing either way. Testing either way makes it harder to
And
overcome.
we had 2 tails because
Not equal to. Alternative. So our conclusion, we failed to reject What was it that we failed to reject?
Wait, why would we fail?
No. Because this is not less.
So I thought that we would reject it.
No, so it's all nots. So not. So we failed to reject the null hypothesis that is the gram calculator? No, gram calculator. Since why? Which means that we
Sorry,
and usually here I switch and go exact wording somewhere in the problem. Which is usually at the bottom. So I do not have enough evidence that
the concentration of the unit is changed.
So even though I said we were going to write it as a mu there, sometimes I switch and go, I think it makes more sense to answer the question directly. Yeah. Questions at this point? I want to show you how to do the whole thing in your calculator just like we did last chapter. Last chapter I told you this, but I also said it's probably not that helpful at this point. I just want to at least... So we've already got our numbers in a list. So that's the way I'm going to do it. So we've got 2.1, 2.5, 2.2, 2.83, 2.2, 2.4, 2.9. I don't think I read this wrong. What? 2.25. All right, so now that I have it in a list, where do I go? So think about how I did interval in my calculator last chapter. Like I said, check it on your test this way. Does anybody remember what button I go to first? Stat gets me here. Now I want to go where? Tests. Well, now this is what we said at first. I click too many buttons. At first, it gives me all these options. So the first 6 are tests. Well, we're there now. So 3 and 4 say 2. Well, we're not in 2 sample yet. 5 and 6 say proportion. We're not done with proportions yet. So we're either a Z or T. So this problem that we just did was a Z. So we're going to the first option. Just like last chapter, I have the option to either type in the data or use stats. Since I have my numbers in my calculator, I'm going to go to data. What is the claimed null hypothesis for this problem? 2.3, what is the standard deviation? 0.3, my numbers are in my list 1. We leave frequency as 1. And here I choose what my alternative was. So my alternative was not equal to. So I did data. This is my claimed null hypothesis. This is my given standard deviation. All my numbers are in list 1. And I'm doing not equal to. And then when I hit calculate, it is going to give me my X bar, which is the 2.5125 that we found. I don't need S because we're using sigma. It's going to give me my Z-score, which is my test statistic. So it gives me this number, but what does it give me what is this? P-value. So what did it actually do for me? It went ahead and, so when I chose not equal to, that meant multiply it by 2 for me.
So how did you get there? You did
Stat test 1. And then that gets you to the right place. So last chapter, I didn't think it was very helpful at all. Here, if it's going to give me at least 3 things directly that I would have had to go type in myself, I now think it's starting to be worth it at this point. So I would suggest using the calculator method. Even if it didn't give me all my data and it just gave me my means and stuff, I would probably still start to use this. But that's totally up to you. We're getting the same thing that we did by hand. You just have to remember that in your calculator, when you clicked not equal to, you are telling it to do 2-tail, which means it multiplies it by 2 for you. Questions?